Hello, this is Dr. Satish Singhal, PhD, Faculty Computer Science, El Camino College, Torrance, California. I want to talk about bubble sort, and it's a very interesting sorting algorithm which would take us 3 parts to explain it fully. In this part 1, we're only going to talk about principles. So we're going to use a PowerPoint where we'll have an array and we'll illustrate to you the principles of bubble sorting. There is a website also. Hopefully I can show that to you, and everything will be done in less than 15 minutes. So let's proceed. First, acknowledgement to Dr. Nell Dale, University of Texas, Austin, who is the original author of slides being used in this presentation. So bubble sort is one of the sorting algorithms for sorting arrays in ascending order or descending order. We are only going to present the logic for ascending order sorting. Descending order can be done the same way. So imagine this is our array here, a values array, where we have 5 elements, 1, 2, 3, 4, 5. These are values 0, 1, 2, 3, and 4. And initially array is not sorted. And what bubble sort does, it divides the array into 2 parts, a sorted part and not yet sorted part, when it finishes one complete iteration through all the array elements. What happens is that each pass finds the largest of the unsorted elements and bubbles it into its correct place, which will be in the proper slot in the sorted array. And each iteration of through the unsorted array, the number of sorted element increased by 1, and of course correspondingly number of unsorted will reduce by 1. Okay, so let's show the mechanism to you. So we start our unsorted array iteration always from the beginning of the array, and we see whether first 2 elements are correctly ordered or not. So if we are sorting array in the ascending order, then 24 should come before 36. So we compare 36 and 24, and since 36 is larger than 24, that's the incorrect order. Because we are sorting in ascending order, 24 should be before 36. So we swap them actually. And once we swap them, it will look, after first swapping, array will look like this. 24 and 36 got swapped. Okay? So these are in correct order. So then we're going to compare the next 2, 1 and 2. And here we again see that 36 is larger than 10. So that's incorrect order. So we swap them. 10 should come before 36. And when we do that, array after second swap looks like this. Notice this will take care later, but at least in each swapping, we have kept the correct order, and correspondingly, the larger value is bubbling towards the end, where it should be in the sorted array. Okay, we keep going. Then we compare 36 and 6. Well, again, 36 is larger than 6, so we need to swap them. And after the third swap, array will look like this. And then we compare 36 and 12. So 36 is larger than 12, so we swap them again. And as soon as that happens, the largest value in the array got bubbled to the last element in the array. And in a way, although array is 1, we have formed a sorted portion And notice our unsorted portion got reduced by 1. Okay, so that's the principle. So next time we need to iterate only through the unsorted array. And this fact that each time you need to iterate through only unsorted array should be remembered when writing the code for bubble sort. Okay, so after the pass 2, 24 will, so go back here. So notice in this 24 is the largest element. So when we complete the second pass, we're going to compare 24 and 10 and put 10 here, 24 here, compare 24 and 6 and so on. So really the 24 after pass through this unsorted array, 24 should bubble here, and that's exactly what happens. So now we increase the sorted array by 2, one more element became 2, and unsorted reduced to just 3 elements. So that's basically the principle. And of course, at the end of the pass 3, the array will be sorted, completely sorted. In this case, some cases may not be sorted, and it's not going to change after pass 4, and after pass 4, the array is sorted. Okay. So that's the theory of the bubble sort. That's the sorted array. Okay. So I also wanted to show you, I have a few more minutes left, a Java applet which is at the Harvard University website, and that will also help you understand how the bubble sort works. Principle there will be exactly like I showed here, but it gives you another way to look at it, and it would not be a bad thing to include that. Okay, so how do we find the Java applet? Okay, so I need to go to wireless here, and then I start my browser. Okay, connected, Chrome, and I always use incognito because I don't want to delete my history. This way it doesn't record the history. So we just type here Harvard University X sort lab. Okay, bit, and that's the web address. That's the web address. If you want to see in depth, I can use a Microsoft Word document and put it here in more detail. New blank document, and to make it a little bigger, I can bold it, and font could be a little bigger. Okay, that's too big. Okay, so that's the web address. If you want to note it down, you can pause the video right now and note it down. Okay, let me go back to my Java applet. Okay, so it looks like, okay, so it looks like they remove the Java version. Okay, it says your browser doesn't do Java. I have to put the Java in there, but we can use in the meantime, we can use the JavaScript version of this, which is here, which will run right now. And here I'm going to select the bubble sort and new sort, of course. And here there are 16 elements in this array, index 0 to 15. And this shows you, height of the bar shows you the value stored in a certain array element. Okay, so this is larger than this. So we're going to see the same thing here, that we're going to start from the beginning, compare the neighbors. If left neighbor is larger than the right neighbor, then we're going to do the swap. I'm going to do it slow first, but watch the comparisons and the copies. Okay, number of comparisons simply depends upon number of elements being in the array, but copies depend a lot on how the array is originally arranged. Okay, so I'm going to do the step. So it's going to compare these two. One is larger than 2. So if I do one more step, it's going to swap them. See? And now we're going to compare these two. This is larger than that. So it's going to do, as soon as I do this step, it's going to swap them again. And you can dynamically, what's going on, read here, although I'm describing that in words. Now if you compare these two, same thing. This is larger than that. So we're going to do a swap again. This is larger than that, so we're going to do the swap again. And looks like we found the largest in the array, so we'll keep swapping until the end. So we're going to swap these two. And we're going to swap 7 and 8. And we're going to swap 8 and 9. And we're going to swap 9 and 10. And 10 and 11. And you can see copies keep increasing, because each time we do a swap, there are 3 copies. Then we're going to swap 11 and 12, because 11 is larger than 12, and that's the wrong order. And then we'll swap 12 and 13. And we just keep swapping until this largest element goes to the end. That's it. So we have created a sorted portion and unsorted portion decreased by 1. Now I'm going to give it a step. Now just going to run it so you can see how it's going to do the comparisons and swapping. Obviously these two will be swapped, and after that this is the larger than both of these, so after that this will not be swapped. So let's see the run and see. You just watch here now and see how it works. Actually, I'm going to be quiet for a while. You can see it's swapping each time left neighbor is larger than the right neighbor. Each time swap happens, this increases by 3. Okay, so in the second iteration, second pass through the unsorted array, one more element got added to the sorted array, and unsorted reduced by 1. Now I'm going to run it, but I'm going to run it fast so that we don't have to spend that much time. There you go. Third pass is over. Fourth pass is over. Watch the copies. Even though array is sorted, it's still going to go through the unsorted portion and make the comparison, although there will not be copies when array is already sorted. In comparison based algorithm, number of comparisons strictly depends upon the length of the array. Larger is the array, larger will be comparisons. But number of copies depend upon how many swaps you have to make. Okay, and number of swaps in bubble sort is very high. That slows down the algorithm. That problem is solved in the next algorithm called selection sort. Thank you. My time is about to be over. Thanks for watching Bubble Sort Part 1.